All right, now that we've done some work with some graphs and functions, we're going to tie them together and put them in motion. So first of all, a translation. This should be a little bit of review. It's just moving our graph horizontally, vertically, or both, right? So I can move horizontally, I can move vertically, or if I do both, that would be like a diagonal move, right? Because I'd go horizontally and vertically, right? Don't think of it as diagonal. Think of it as a move in the X direction and the Y direction. Okay, that'll be helpful. So first of all, we could see something like this. We get a graph, and it might be helpful to write the equation of the line. So let's go ahead and do that. And when you're given a graph, it should be easy just to go slope-intercept form because I can count the slope and I can look at the y-intercept. So in this case, the slope, well, let's find 2 points. So I got 0, 0 here and 1, 2. So I could really just count the slope, right? The rise over the run. So it goes up 2, right 1. So 2 over 1 for the slope, so which is really 2x. And then the y-intercept, well, it's right at the origin there, so plus 0. So it's really just y equals 2x for that slope. Okay, perfect. All right. Well, what about if we decide to take that equation and shift it up 3 units? What do you think would be done to our equation up here? Well, I'm at y equals 2x, and if I shift it up 3 units, really that just affects what? Yeah, the y-intercept. So it should just go up 3. And let's double check. So when you shift a graph, don't pay attention to the whole graph. Just pay attention to one point in particular, and that'll help you out. So in this case, I'm going to pay attention to the origin. If I shift it up 3, it's right there. And if I wanted to do the graph, I would just use the slope then, or I could find other points to move up 3. Well, the slope is up 2, right 1. So there we go. I could also go down 2, left 1, and I could graph that guy in just like that. Should be parallel, right, because they have the same slope. And there we go. So in that case, I kind of could tell what the equation of the line would be, but if not, I would just go ahead and find a point, move it up 3, and then take a look and rewrite my equation. What about if our original line were shifted right 2 units? Okay, so let's go back to our original line. Now it's a little bit trickier. So now I might want to take that line, take a point on that line, and shift it right. So since I got that y-intercept at 0, I'm going to shift that right 2 units. So 1, 2. So there's my new point. Then I'm going to use my slope up 2, right 1, or down 2, left 1, down 2, left 1. I might just do it a couple times, so I got that. And there we go. So here, same thing. I could just say y equals, I can tell. My slope was 2, so 2x still, but now my y-intercept is -4. Okay, so that was kind of tricky. And what you're going to find out, we're going to find an actual equation to use to do this for us. Really what I did was, I took my original equation, y equals 2x, and to shift it right 2 units, what I do is, inside my x, I subtract 2. I know it's kind of the opposite, but that's how it works. And then when I simplify this guy, I distribute the 2, and it's 2x, and distribute here, so -4. And that works out, right? That's the same equation. Kind of confusing right now, but we'll take a look and see why that works in just a little bit. Okay, same thing, you get something like this. You could get a line, and you want to write a line that's parallel to it that goes through a certain point. Well, what would be helpful? Yeah, if I knew the equation of this black line here. So can I figure it out? I could say y equals, well, let's find its slope. So here's a point I know. Here's another point I know. Rise is 2. Run of 1, 2, 3, 4. So really it's a slope of 1/2. Simplify that 2/4. And its y-intercept was 0 again. So really this equation is just y equals 1/2 x. Okay. And now I know the equation I'm going to write is going to have the same slope, and it goes through the point 3, 4. So if you have a slope and a point, or a point and a slope, what should you use? Yeah, point-slope form. So y equals m times x minus x1 plus y1. Plug in your information, so our slope was 1/2 x minus 3 plus 4. Right, I'm just plugging in 3 for x1, 4 for y1. And then we simplify. So I got 1/2 x minus 3 halves plus 4. And 1/2 x, what's -3 halves plus 4? Well, that -3 halves is really -1 and 1/2. So really we have 2 halves. And I could graph that, so I got a y-intercept at 2.5. And it's going up 1, right 2. Up 1, right 2. And so right there. And up 1, right 2. So right there. So there we go. It's parallel. It goes to the point 3, 4. And I got my equation of my line right there. Okay, so we're using some information that we knew previous to help us solve this guy. And there's also another way I could do this. Okay, so what we're going to find out in just a bit is that we have an equation to translate a graph, a linear graph. So if I looked at this point right here, and I want to go to this point right here, I'm basically moving that graph because it's parallel, right? I really went left 1, and then I went up 2. So we'll find out in just a bit that I actually have an equation that I have my y equals mx plus b, and all that really gets affected is it's almost like our point slope form in a way. I take my x and I subtract how it moves in the x direction, and I take my y-intercept and I add how it moves in the y direction. Okay, I'm using h and k. It's super confusing why I'm doing this right now, but I just want to show you why it works. So I do y equals 1/2 x minus what moved left 1, right? So that would be -1. So that's really x plus 1, plus my y-intercept was 0 in this guy, plus k, well, it went up 2, so plus 2. And if I simplify this whole thing, I'd have y equals 1/2 x plus 1/2 plus 2. Well, what do I get? The exact same equation right here. So it works out. So kind of confusing how I did that, but we'll take a look and why that works in just a second. And before we get there, let's take a look at something that's not a straight line. That's not just a perfect line. It says, if this is the original function, how has each graph been moved? Well, like I said before, don't pay attention to the whole graph. Just pick a point that you want to deal with and just move that one point. That's much easier to tell. So the easiest one I would say would be this guy right here, the point 0, 2. And then I just look for A. Well, how did that point get affected? It went from here and it went down 2. So that went down 2 units. So much easier to look at just one point. Okay, same thing. My original was right here. It went up 1, 2, 3. Up 3 units. So on and so forth. Okay, my original was at 0, 2. And now we went 1, 2, 3 to the right. So right 3. And lastly, my original was 0, 2. Now I went, what? Left 2. And then we also went 1, 2, 3. Down 3. Okay, so just deal with one point at a time. That seems to be much easier. And deal with where you start to where you finish, right? So our starting was always 0, 2. That was the point I dealt with. And then I moved from there. So now let's take a look at the equation. Okay, so for a translation of a function, a translation of, well, in this case, we did an equation of a linear equation, first of all, and then we did a function next. But let's say we have a function, and we call it f of x, y equals f of x. All that happens is we subtract h, and h is our x direction, and we add k, which is our y direction. So x, whether you moved left or right, k, whether you moved up or down. And another way to write this equation is I could have this k on the other side. I could really subtract k to the other side. I could write this as y minus k equals f of x minus h. I could do that as well. Either way is just fine. Okay, we're going to deal with my main one here. So I'm just going to erase that so we don't look at both those. So it looks like h is for how far the graph translates in the x direction. So for example, if I'm going to go right 4, I would say y equals f of x minus, well, positive 4 for h, plus k, whatever that happens to be. So our h was a positive 4. Over here, we're going left 3, so our h is going to be a negative 3. So I would say y equals f of x minus a negative 3, which is really plus 3, and then plus our k, whatever happens to be. And if there is no movement up or down, then we don't have a plus k there. It's just like that. Okay, same thing for the up and down, but now we're just dealing with the k's. So in this case, if I go up 5, that means k is a positive 5. So I'd say y equals f of x plus 5, right? Because it's just plus k. And I'm not minusing any h, so I can just say f of x. I don't need that h in there. And over here, same thing. Our h is going to be a negative 7 now, so y equals f of x minus 7. All right, so let's actually use this. Let's go what we originally did, and let's write equations for it. So now we're saying that this graph over here is y equals f of x. Okay, and we said that it moved down 2, right? Because we looked at the 1 point, is that 0, 2, and it went down 2 spots. So my equation, my new equation would be y equals f of x. Well, remember that down 2 means our k is going to be a negative 2, so minus 2. So that would be my equation for that function. All right, what about for b? Well, we went up 3, right? So up 3, so it's the same thing, f of x, but now we added 3. Okay? How about for c? Well, we're at 0, 2, and we went right 3. So right 3, so now we go y equals, this is the tricky one, y equals f of x, not plus 3, but minus 3. That's the opposite one. And we don't need any plus or minus k because it didn't move up or down. So I'm done right there. And then lastly, now we got 2 moves. So we're at 0, 2. We said it moved left 2 and then down 3. So left 2, down 3. So now I'm going to say y equals f of x minus negative 2. Be careful, right? Because left is a negative, and it's minus, so minus negative 2, which is really a plus 2, and then down 3, so minus 3. So there would be my equation. Y equals f of x plus 2 minus 3. Okay, so we're just kind of getting used to how our equation gets adjusted, and this will be helpful once we get into some real equations that we use, like quadratics and linear equations and things like that.